Okay. So H-fill algorithm fill the polygon in scanned line order. We have seen three types of algorithm: H-fill algorithm, fence-fill algorithm, and H-flag algorithm. So whatever the polygon here, suppose this is the polygon in this way. So this polygon is filled here according to the scan line. This scan line is first filled, then this one, then this one, then this one, this is one. So H-fill algorithm fill the polygon in scan line order. The seed fill algorithm assumes that at least one pixel is filled with the polygon value. The seed fill algorithm, how it works here, suppose this is the pixels and this is our polygon. Okay, so here it is considered that one of the pixel is filled with the polygon value. So assume that at least one pixel interior to the polygon or region is known. So I know that this pixel and it is filled with the polygon value. Algorithm attempts to find and fill all other pixels. After this, it tried to find out all other pixels which comes under the or interior to the polygon and fill that pixel one by one. That's why it is known as seed fill algorithm. There are two methods for the seed fill algorithm: interior and boundary defined. Now see detail, interior and boundary defined. So see here, what is the major difference between these two first? Or the definition of interior defined region and boundary defined region. There are two ways in which we can apply the seed fill algorithm. So interior define all pixels in the interior of the region one by one color or value all the pixels in one color, interior in one color and exterior means these are in another color. Okay, all pixels in the interior of the region are one color or value and all pixels which are outside are another color. We call it as a background color, here another color. Similarly, here opposite to that, all the pixels boundary is considered. So all the pixels on the region of the boundary, here you can see boundary, these are filled first, has unique value, and then using that the polygon is filled. That using the boundary value, the polygon is filled here one by one. Algorithm that fill interior defined regions are known as fluid fill algorithm. So this algorithm is known where the interior region has one color. It is known as flood fill algorithm. Algorithm that fill boundary defined regions are known as boundary fill algorithms. It's a time consuming. It requires less time. Both we are going to see. Again see interior defined region and boundary defined region. There are two methods. In the interior defined region, all the interior part of the polygon is filled with one color and all the exterior part is filled with another color. While in this, all pixels on the boundary region are first defined unique value and then according to the interior region is filled with one color. This algorithm is known as flood fill while this algorithm is known as boundary fill algorithm. It is time consuming while it is requires less time. Now see these both the algorithms, interior or boundary defined regions are either 4 connected or 8 connected. 4 connected means these are the pixels positions that are right, left, top and right, left, above and below the current pixel. Means if this is a pixel, then 4 pixels are found here. Okay, 4 pixel positions are considered right, left, above and below. And in 8 connected, here first this pixel position is there and all the neighbors along with the diagonals are also considered here. So right, left, above, below and all the diagonals are considered here. So here you can see 8 pixels are there, totally 1, 2, 3, 4, 5, 6, 7, 8 pixels are found which are neighbor to the pixel and here only 4 pixels are considered. Now the algorithm, simple algorithm, first simple seed fill algorithm only we are going to study here. To see here. First, the simple statement wise the algorithm will see, and then we will see the detailed pseudocode of the algorithm. A simple seed fill algorithm for boundary defined regions can be developed using a stack. So here the stack is used for implementation of this seed fill algorithm. What is stack main feature? Last in, first out. LIFO. It has a LIFO feature, that is last in or LIFO we call it. Last in, first out. So whenever we pop the element, the which element is popped here, which is on the top of the stack. It is popped here. So simple stack is used here to implement this algorithm, and here we are going to consider only 4 connected method or 4 connected pixels. Means if a pixel is there, then we consider it's a right pixel, above pixel, left pixel and below pixel. Okay, one by one, first this, then this one and this one. So in this way we go one by one, the filling the color of the pixel, and these pixels we put on the or push it on the stack. Push it on the stack. So simple seed fill algorithm using stack. Push the seed pixel onto the stack. The pixel. This pixel I want to first need to push on the stack. Okay. After that, while the stack is not empty, if the stack is not empty, pop a pixel from the stack. Pop the pixel from the stack. Set the pixel to the required value. Means whatever the value of the polygon, set it to the required value. For each of the 4 connected pixels, adjacent to the current pixel, check if it is a boundary pixel or if it is already been set to the required value. If it is a boundary pixel and if it is already set to the required polygon value, then ignore it. Otherwise, push it onto the stack. Means first this one we push onto the stack, then we go for this one. If this is not the boundary value and if it is not already filled with the polygon value, then that pixel is pushed onto the stack. Then we move towards the next, this one. If this pixel is not boundary value, boundary pixel, or if it is already not filled with polygon value, then push it on the stack. Then we move to the next, this pixel. If it is not the boundary pixel and if it has already not set with the polygon value, then push it on the stack. And then this one. And then pop it one by one again and set it with the required value. Now see in detail the algorithm. Okay. So simple seed fill algorithm for 4 connected boundary defined region. Seed XY is the seed pixel. Here in this example, what is this seed XY? This one. This pixel is considered it's the already filled with the polygon value. What is it? 4 and this one 3. So this 4, 3 is a seed pixel which already given the polygon value. Okay, this is seed pixel. Push is a function for placing a pixel on the stack. Pop is a function for removing a pixel from the stack, that you know in the data structure. We already studied it. Now pixel xy is equal to seed xy. So this first seed pixel 4, 3 is the first pixel that we are going to consider. That is pixel 4, 3. 4, 3. Initialize the stack. So push pixel here, this pixel 4, 3. Okay, push pixel x, y. What is now? It is 4, 3. Now, while stack is not empty, get a pixel from the stack. Where the stack is not empty, so pop this pixel from the stack. If this pixel is not equal to new value, then assign it a new value. If this pixel is not equal to the new value, assign it a new value. Next, now if pixel, now previously what we have seen, if the pixel that xy, whatever here, it is not set to the new value. What is the new value? Value that is polygon value. Suppose we want to fill the polygon with the green color. If it is not with the green color, then assign a green color to this pixel. After that, next. Okay. After that, if pixel x plus 1 comma y, x plus 1 means what? This one. X plus 1 means 5 comma 3. What is xy here? 4 comma 3. This is x and this is y. So the next we are going to see x plus 1 comma y means 5 comma 3. Now check this pixel 5 comma 3. If this pixel is not equal to new value, means the polygon value, and not equal to the boundary value, then push this pixel onto the stack. Then push this pixel on the stack. Means if it is 5 comma 3 is not the polygon value or it is not the boundary value, then push it onto the stack. And if pixel x comma y plus 1, x comma y plus 1, what is x? 4 comma y plus 1, 4. So 4 comma 4 means this pixel, 4 comma 4. If this pixel is not equal to new value, polygon value, not equal to boundary value, then push this pixel onto the stack. Push this pixel onto the stack. Now the next, x minus 1 comma x minus 1 comma y. So x is 4, so it is 3 comma 3 means this pixel. If this pixel is not equal to the polygon value and if it is not equal to the boundary value, then push that pixel onto the stack. And the last one, the below. What is it? X comma y minus 1. So it is 4 comma x 4 comma 2 means this one. 4 comma 2. So this pixel, if it is not equal to the new value and if it is not equal to the boundary value, then push that pixel onto the stack. Again start with the first. Okay, push pixel x comma y. That after that, if stack is empty, no, the stack is not empty. So if the stack is not empty, then pop the pixel, this first pop it. Check whether it is a new value or the polygon value. If it is not, then assign it a new value. Again for that pixel, check the right, up, above, left and below pixel. Now see it with example, then it becomes again the simple to understand. Only remember that here we are going to start with the pixel, seed pixel we call, whose value already given the polygon value. And from that pixel first we push onto the stack and then pop it from the stack. If stack is not empty, then we find out its right, then we find out its above, its left and its bottom or below. All these 4 pixels push onto the stack. Then the last one, that means this one, pop it from the stack. Again start with its right, then up or above, left and below. Now it is at the end, so pop it from the stack. Now this one, this one, this one, this one. But it is a boundary, so it is not considered. See it with example. We'll see the example in detail here so that you can understand it. So according to the algorithm, we consider here the polygon is of green color. Okay. So where I write this one? 1 minute. I write it here so that you can understand. 1 minute. Now we start with the seed pixel. What is our seed pixel? This is our seed pixel. What is it number? 4, 3. So the first seed pixel is 4, 3. So that one we push onto the stack 4, 3. First we push into the stack 4, 3. After that, the stack is not empty according to the algorithm. So we pop it. 4, 3. After that, check whether it has a colored with polygon value. If it is not colored with the polygon value, then color it with the polygon value. But it is already colored with the polygon value, so not necessary to do anything. Now we start with the surrounding pixels. The pixel to this right, what is it? X plus 1, y. What is x plus 1? 4 plus 1, that is 5, y, that is 3, means this pixel. 5, 3 pixel. Now 5, 3, it is on the right hand side. Whether it is equal to or it is not equal to new value, it is not equal to the boundary value. Correct? These are the boundary values. These are boundary values. So this pixel 5, 3, it is not equal to the new value and it is not equal to the boundary value. So we push that pixel onto the stack. So what is that? 5, 3 we push onto the stack. Next, x, y plus 1 means this one. X, y plus 1 means 4, 4. So 4, 4, this pixel, it is not equal to the new value. It is not equal to the boundary value. So push that pixel onto the stack. Push that pixel onto the stack. Now we move towards the next one. X minus 1, y. X minus 1, y means 4, 3, 3. X minus 1, y means 3, 3. So this pixel is not equal to the new value. It is not equal to the boundary value. So put this pixel or push pixel onto the stack. After that, the next one, x, y minus 1 means the pixel which is below. X, y minus 1 means it is 4, 2. So 4, 2, you can observe it is not equal to the new value. It is not equal to the boundary value. So push that pixel onto the stack. Again start with the first. Stack is empty. Stack is not empty. So pop it from the stack. Pop means the last in first out. So pop it from the stack. So this is first popped and this is second popped. Now pop it from the stack. Check its color. Whether it has a new color. This 4, 2. Where it is 4, 2. This one. Whether it is a new color? No. It has an old color. So assign it a new color means the polygon value. Okay. So now this pixel is filled with the polygon value. Now check the pixels which are right, above, left and bottom to this pixel. So which pixel is right? X plus 1, y. So x plus 1, y means it becomes 5, 2. Okay. What is this pixel now we are looking? 5, 2. Now above pixel, what is it? 4, 3. But 4, 3, whether it is a new value? Yes, it is already new value. Not necessary to push that pixel onto the stack. See, once again I am repeating. Now this pixel is filled with the polygon value. We are looking for its right, above, left and below. Right is 5, 2. Right, push it. Why? It has not a new value. It is not a boundary value. So push it onto the stack. Now above is 4, 3. 4, 3, already it has a new value. If it is already new value, then not necessary. Push it, ignore it, go for the next one, that is left one. What is left? 3, 2. So 3, 2, whether it is a new value? No. Whether it is a boundary value? No. So push it onto the stack 3, 2. After that, the below, what is this? 4, 1. The below is 4 comma 1. So 4 comma 1, whether it is a new value? No. Whether it is a boundary value? No. Then push it onto the stack 4 comma 1. Now after that, stack is not empty, so pop it. So this is the third pixel we pop. Now whether it is a new value? No, it is not a new value. 4 comma 1, it is not a new value, so assign it a new value. Assign it a new value, and now check its right, above, left and below. Now what is its right? 5 comma 1. So 5 comma 1, this one, it's a right 5 comma 1. Whether it is not equal to the new value, it is not equal to the boundary value, so push it onto the stack 5 comma 1. Now the left one, for this the left is this one, that is 3 comma 1. 3 comma 1 is not equal to the boundary value, not equal to the new value, so push it onto the stack, that is 3 comma 1. Next, the below. Now below is 4 comma 0. What is below? 4x comma y minus 1. So it is 4 comma 0. Now what is it? It is equal to the boundary value. So it is equal to the boundary value, so ignore it. If it is not equal to the boundary value, it is not equal to the new value, then only we push it onto the stack. But it is equal to boundary value, so ignore it. Not equal to push onto the stack. Now we pop an item from the stack. Stack is not empty, so this is the fourth element. This we pop it from the stack. 3 comma 1. What is its color? Whether it is a new value? No, it is not a new value, so assign it a new value. Assign it a new value. Now this is the pixel for which we are going to say its right, above, left and below. So what is its right? 4 comma 1. Okay, 4 comma 1, which is already a new value. It is already a new value, so ignore it. What is its above? 3 comma 2. 3 comma 2, whether it is equal to new value? No. Whether it is equal to boundary value? No. So push it on the stack 3 comma 2. But 3 comma 2, you can observe it is already there on the stack. It is already there in the stack, so not necessary to again push it on the stack. After that, 3 comma 2, next is the left. What is left? 2 comma 1. So 2 comma 1, it is not equal to the new value, it is not equal to the boundary value, and that's why this one we are going to push onto the stack, that is 2 comma 1. After that, the below, what is it? 3 comma 0. 3 comma 0, it is a boundary value, and that's why don't do anything, ignore it. So here the stack is not empty, and that's why we need to pop this element. This is the fifth element popped up from the stack. 2 comma 1. What is its color? Is it equal to new color? No, it is not equal to the new color, and that's why give it a new color. Once it is new color, now see its right, above, left and below. What is its right? 3 comma 1. But 3 comma 1 is already colored, correct? 3 comma 1 is already colored, so ignore it. After that, it's above. What is above? It is 2 comma 2. 2 comma 2, it is not a new value. It is not equal to new value. It is not equal to boundary value. It is already not on the stack, so push it onto the stack. Now it's left 1 comma 1. So 1 comma 1, it is not equal to the new value. It is not equal to the boundary value, and it is not on the stack already. So 1 comma 1, push onto the stack. Now this one as a below, but it is equal to the boundary value, so ignore it. Now stack is not empty, so pop it. This is the sixth element, 1 comma 1. Now it is not equal to the new value, so color it with the new value. It is not equal to the new value, so color it with the new value. After that, see its right. What is its right? It is 2 comma 1, which is already equal to the new value, so ignore it. What is its up or above? It is 1 comma 2. 1 comma 2, it is not equal to new value, it is not equal to boundary value, and that's why push it onto the stack. That is 1 comma 2. Then it's a left, it is equal to the boundary value, so ignore it. It's a down, it is also equal to the boundary value, so ignore it. Now the stack is not empty, so pop it. This is the 7th element that we pop, 1 comma 2. Its color is not equal to the new value, so color it with the new value. So color it with the new value. After that, the next, for this 1 comma 2, see its right. What is its right? 2 comma 1. What is its right? Sorry, 2 comma 2. For this 1 comma 2, what is its right? 2 comma 2, but 2 comma 2 is already on the stack, not necessary. Next, its up is this one, that is 1 comma 3. 1 comma 3 is not equal to the new value, not equal to the boundary value, so push it onto the stack. This is equal to the boundary value, ignore it. This is already colored with the polygon value, so not going to push onto the stack. After that, again the stack is not empty, pop it. The 8th element that we are going to pop, that is 1 comma 3. So 1 comma 3, it is not equal to the new value, so I assign it a new value. Now check its right. What is it? It is 2 comma 3. So 2 comma 3, it is not equal to the new value, it is not equal to the boundary value, so assign it or push it onto the stack. 2 comma 3. After this, its up is 1 comma 4. 1 comma 4 is not equal to the new value, this one not equal to the boundary value, and it is not onto the stack, so push 1 comma 4. Now its left, this is the boundary value, its bottom already new value, not necessary to push onto the stack. Now stack is not empty, so pop this element, 9th element, 1 comma 4. So 1 comma 4, it is not equal to the new value, so assign it a new value. Now next its right. What is its right? 2 comma 4, which is not equal to the new value, which is not equal to the boundary value, push it onto the stack. What is its up? 1 comma 5. So 1 comma 5 not equal to the new value, not equal to the boundary value, and not onto the stack, so push it onto the stack. 1 comma 5. Its left is the boundary value, and its bottom is already new value, polygon value, so not necessary to push onto the stack. Now pop it. Pop it as the 10th element, 1 comma 5. So 1 comma 5, you can observe here, it is not equal to the new value, so assign it a new value. Okay. Now this pixel, what is its right? 2 comma 5. So I am going to write it here again, that 2 comma 5, it is this 2 comma 5, this pixel we are going to consider now, and its right, that is 2 comma 5, it is not equal to the new value, it is not equal to the boundary value, it is not on the stack already, so push it onto the stack. Now up, it is boundary value, so ignore it, not necessary to push. It's a boundary value, not necessary to push, and this one already filled. It's a below, already filled, so not necessary to push. Now this is on about the top of the stack, so pop it. This is the 11th pixel, pop it. So pop, check whether it is a new value. No, it is not equal to the new value, so assign it a new value. Now check its right side. It is 3 comma 5. 3 comma 5 is not equal to the new value. It is not equal to the boundary value. So that one 3 comma 5, push it onto the stack. Then it's up above. It is a boundary value, so not necessary to push onto the stack. This one already colored with the new value, not necessary to push onto the stack, and this one, it is 2 comma 4. but 2, 4 is already there onto the stack. You can observe here. So again, not necessary to push. Now the top of the element, this we are going to pop at the 20th element 3, 5. Whether it is a new value? No, it is not equal to the new value. So color it with the new value. Color it with the new value. After that, 3, 5, its right is 4, 5. 4, 5 is not equal to the new value. It is not equal to the boundary value, and it is not already on the stack. So push 4, 5 onto the stack. Then this 4, 5, its up is boundary value, not necessary to push onto the stack. Its left is already new value, not necessary to push onto the stack. And its bottom or the below, what is it? 3, 4. 3, 4, it is not equal to the new value. 3, 4, sorry, this one. It is not equal to the new value. It is not equal to the boundary value, and it is already not onto the stack. So this 3, 4, we need to push onto the stack. Now the stack is not empty. So pop it. 13th element, which is 3, 4, this one. It is not equal to the new value, so assign it a new value. Okay. After that, the next one. After that, 3, 4, what is its right? 4, 5. So 4, 5, it is not equal to the new value. It is not equal to the boundary value. So that one push need to be pushed. But 4, 5 already there. And that's why not necessary to push it again. Now for that up, this above already new value, so not necessary to push. This one is 2, 4. 2, 4, it is not equal to the new value. It is not equal to the boundary value, but it is already there on the stack. So not necessary to push it again. And this one, it is 3, 3, which is already onto the stack. 3, 3, it is here onto the stack. So not necessary to push again. Now, what is the top of the stack? This 4, 5 is the top of the stack. So pop it. Stack is not empty. So pop it. This is the 14th 4, 5, where it is 4, 5. Okay. Now check its right, up, down, and left and down. So in this way, when we continue it color pixels one by one, all the pixels which are interior or which are interior to this boundary pixels. One by one, we can color it. Okay, so 3, 4 is here. After that, the next one is for 3, 4. So for 3, 4, this pixel is colored with the new color. Then what is its right? It is 4, 4. Its right is 4, 4, which is not with the new value, not with the boundary value, but it is already on the stack. It's up, above. This one is already new color. This one, for this one, that is 2, 4, it is already onto the stack. Then this one below. So this below, it is 3, 3, which is already onto the stack, not a boundary color, not a new color, but it is already onto the stack. So pop, next one, we need to pop it. Which one? 5, 5. So pop it. Then for that, we assign the new value, and then 5, 5 is here. 5, 5, it is here. And one by one, the pixel is colored with the interior color in this way. Only boundary colors or this one are kept as it is. These are the boundary values. These are the background colors, and this is the interior is filled with the color. If there is a hole in the polygon, then in that case, how to fill this polygon? Okay. So last lecture we have seen the algorithm, previous example we have seen. Now with hole, how to perform this or fill algorithm, how it work if there is a hole in the polygon. So again I am going to draw here one stack. Start with here the point this one. So first this point, what is that? 4, 4. It is filled according to the algorithm. First 4, 4 point is filled and that is pushed onto the stack, and then the stack is not empty, so it is pop from the stack. That is the first point we fill with the color. We consider here the polygon we are going to fill with the blue color. Now once this visited, the next one, write to this up, left and below. So which pixel is on the right of this? 5, 4. So 5, 4, whether it is a new color? No. Whether it is a boundary value? No. So in that case 5, 4 we push onto the stack. After that above, that is 4, 5. So whether it is a new color? No. Whether it is a boundary color? No. So we push that one onto the stack, that is 4, 5. After that, the left one, it is 3, 4. So whether it is a new color? No. Whether it is a boundary color? No. So we push it onto the stack, that is 3, 4. Now the below. Now the below element 4, 3. It is a hole, and that's why that we are not going to consider, not necessary to push onto the stack. Now again start with the first, whether the stack is empty? No. So pop one element from the stack. This is the second element we pop from the stack. Now whether it's 3, 4, what is that? 3, 4, where it is 3, 4. So whether it is a new value? No. So assign it a new value according to the simple seed fill algorithm. Assign it a new value. Next, this color is filled. Now check all the 4 connected to this right one. Right one is 4, 4, which is already colored with the new value. So ignore it, not necessary to push. Above it, it is 3, 5. So 3, 5, this pixel has no new color, no boundary color, and also it is not on the stack. So we push it onto the stack, that is 3, 5. After that, the left element. Now the left element 2, 4. It has no new value. It has no boundary value. So push it onto the stack. Next, below. The below element, it is a hole. Not necessary to consider. Not necessary to push it onto the stack. Ignore it. Now the stack is not empty. So pop the element on the top of the stack. This is the third element that we are going to pop. 2, 4. So whether it has a new color? No. So assign it a new color. Now check the 4 connected pixels to this pixel 2, 4, right one. Right one 3, 4 already colored with the new value. Ignore it. Up is the 2, 5. So 2, 5, it has no new color. It has no boundary value, and that's why push it onto the stack, that is 2, 5. After that, the next one is the left one. It is 1, 4. It has no new color. It has no boundary value. So push it onto the stack, that is 1, 4. Okay. Now the below one. Below to this one is 2, 3. It has no new color. It has no boundary value. So push it onto the stack, that is 2, 3. Push it onto the stack, that is 2, 3. Now 4 connected pixels we visited. Now the stack is not empty. Pop the element on the top of the stack. This is the fourth element that we are going to pop. So That element 2, 3, it has no new value, so assign it a new value. Now check all the 4 connected pixels to this pixel. The first one is the right one is whole. So not necessary to consider. Up is already colored with the new value, not necessary consider. Then left 1, 3. It has no new value. It is not equal to the boundary value, so push it onto the stack. That is 1, 3. That is 1, 3. Then below is 2, 2. It is not a new value. It is not equal to the boundary value, so push it onto the stack. That is 2, 2. Now all the 4 connected pixels completed, visited. So stack is not empty. So pop the top element. This is the 5th element that we are going to pop. So 2, 2. Whether it is a new value? No. So assign it a new value. Assign it a new value. Now check 4 connected pixels to this one, right? It is a whole, not necessary consider. This one, it is already colored with the new value. Now the left, that is 1, 2. So 1, 2, this element has no new value. It is not equal to the boundary value, and that's why push it onto the stack. That is 1, 2. Next, below 2, 1. So 2, 1, it is not equal to the new value. It is not equal to the boundary value, and that's why push it onto the stack. That is 2, 1. All 4 pixels are finished. Now top of the stack is not empty, so pop it. This is the 6th element. We are going to pop. So that element 6, 1, 2, 1. This is not equal to the new value, so assign it a new value. Now 2, 1, this element pixel, what is right to this? 3, 1. 3, 1 is not equal to the new value. It is not equal to the boundary value. So push it onto the stack. That is 3, 1. 3, 1. Now up. It is for this element. This is up, which is already colored with the new value. Ignore it. This is left. Left is 1, 1. 1, 1. This pixel is no new value. This is not boundary value. So push it onto the stack. That is 1, 1. Okay. Now all the below to this pixel, the below pixel is this one, which has equal to the boundary value. If it is equal to the boundary value, then not consider it. Don't push it onto the stack. Ignore it. Now the stack is not empty, so pop this element. This is the 7th element that we are going to pop. 1, 1. So it is not equal to the new value, so assign it a new value. Now this pixel we are going to consider. Now write to this pixel, which is already colored with the new value. Up, this is 1, 2, which is already onto the stack. Correct? 1, 2 is already onto the stack. Not necessary to push it again. The left one, it is a boundary value, and that's why we are not going to consider. Ignore it. The below one, again the boundary value, so ignore it. Now the top of the stack, this element is on the top of the stack. Stack is not empty. Pop it. This is the 8th element. What is it? 3, 1. So 3, 1, this one. Whether it is a new value? No. So assign it a new value. Now right of this is this one, 4, 1, which has no new value, which has no boundary value. So push it onto the stack. Above is whole, not necessary consider. Left is already filled with the new value, not necessary to consider again. And below is boundary value, ignore it. Now top of the stack is 4, 1. So pop it. This is the 9th element that we are going to pop. 4, 1. 4, 1 is not the new value, so assign it a new value. Now it's right. 5, 1. 5, 1, it is not equal to new value. It is not equal to boundary value. So push it onto the stack. 5, 1. Okay. Now up to this pixel, the up is whole not necessary consider, left is already filled with the new value, and below is the boundary value, so ignore it. Now top of the stack, this element, pop it, 10th element that we are going to pop. So here it is not equal to the new value, so color it with the new value. Now it's a right, this one. So in this way, when we complete it, it fills the entire polygon. It fills the entire polygon considering the hole. The ignore. Normally when there is a hole in the polygon, we ignore it.